Alright, so I intend this to just be a short standalone video that's simply to show you what's required from the homework so you can just see it with your eyes instead of just relying on a textual description. So it's fairly simple. I want you to be able to draw a ship sprite, and this is the guy here. I'll provide you with this little graphic and you can draw him. So the basic thing is you write the basic sprite stuff that allows you to create this from an image that I give you, and you write a very simple mouse handler that just reacts to mouse clicks and makes it follow the mouse click, so you can draw it wherever you want on the screen. And that seems very simple, and it's fairly simple. But remember, I also said that you want to be able to make it do wrapping around when you get to the edge of the screen. That's a bit more subtle. That means if I come over here, and if I just hold the pointer down, I can do it by dragging, right, instead of clicking all the time. So I just drag. If I drag to here, and he starts to come off the right of the screen, I want him to wrap around on the left of the screen, just like it would in a game of asteroids or something, hypothetically, like that, and actually it goes all the way around. And the same thing top to bottom. If you fall off the bottom of the screen, it starts to draw on the top. So what's really going on here is that there isn't a way of doing this. There isn't like a flag on draw image that allows you to add a wrapping flag. Some graphic systems have that kind of thing. Some old consoles used to have things to do that. It doesn't have it, so you have to do it yourself. So the trick is that in this case here, you have to draw your sprite twice. You have to detect that it's in one of the boundary conditions, so you actually need to draw it where the mouse is, and you need to draw it wherever it needs to be to make the wraparound work. So I'm going to draw it twice, same with the left and right. And I'll give you a big giant hint that I also want it to work for corners, okay? And corners are a tricky case, because in the corners, you're maybe going to have to draw it 4 times. But it's not that hard if you just think about it, right? But it's like that's the only way to do it. Imagine if this was like a wraparound universe, basically on the surface of a torus, or I think topologically that's what it would be. So you need to make it wrap around, right? So you just have to detect. And it's not too hard, right? With a bit of thought, you can make this work. So that's what you want your sprite to do. Also, I said you want to support rotation because we know how to use our matrix trick to do that. So it turns out if I press A and D, I can also rotate this little guy. And that's still true when I'm dragging him about. So I can do stuff like this, right? So that's beginning to be something. So that's basically part 1 of your homework, is to implement the things that are needed to make that happen within my framework. So my framework's running behind it. So I've got all this stuff, the delta time and all this stuff from last week is all there for you, so that the time handling is correct. So that's part 1 of it. The next lecture today is going to be about part 2, which says, well, if you've got to this stage, you've both to draw the spaceship and you can rotate it and stuff like that and drag it around. It'd be nice if you could fly it, wouldn't it? So you press W and it flies and comes off the top and the bottom and goes like this. And you notice that it's flying kind of like a spaceship, which is to say it's got inertia. Like I'm not holding the keys right now, so it's continuing to travel even though I'm not pressing anything. But when you press thrust, it kind of changes direction a little bit. It doesn't just go where you want to go. It's like it's traveling this way, and then it thrusts in the direction that it's facing. So it'll thrust down, but it'll be also moving to the left as well. So it really moves like a spaceship. It's got like a real inertia and stuff. So this is like, maybe the kind of simplest physics system you could think of. So I can drive this thing. So in order to slow down, I have to turn round against the direction I'm traveling and counter thrust to kind of retro, right? So I can do that. So now I've got a little spaceship guy. And I figured, well, if you've got this and you get the beginning of a physics system, we might as well add gravity. So if you press G as a toggle, suddenly a large planet appears. You don't have to draw the planet, it just magically appears. And then gravity kicks in. And we'll make it simple, so gravity just acts vertically. So if we take him here and we get him to basically stop, like that, and you switch gravity on, boing, and he hits the magical, surface of the planet, or just some magical ground thing. And there's another barrier at the top as well, so if you try and fly away, you hit the top barrier. Only when gravity's on. And because this is inside my framework, if I press C and I stop clearing the screen, you actually get this. So you can kind of see what it looks like. And you can spin around and fly while this is happening and bounce around like an idiot. So that was gravity, and you can toggle it back off. And then it just goes linearly. And when the gravity goes off, the boundaries go off as well. We'll forget clearing the screen. You can press H to make him halt, because sometimes you just want to make him stop. So that just resets him. In fact, you can actually literally reset him as well. There's an R key that will reset the character like that. So there's a couple of things you have to do, and it's all in the instructions what you need to be able to do, but those are the basics. Then the other thing I thought I'd do is, for reasons that will become apparent, if you got one spaceship, you could just as easily have another and another. But actually, I want you to do three. Right? Like 3 spaceships, all controlled the same way, so they move as like a little fleet. Right? They move as a little battalion. There's a particular reason that I'm doing this, though, because part of what I'm going to teach you next is about this whole thing about the sensitivity to frame rates. So these 3 spaceships, one of them is running at 60 hertz, one of them is running at 30 hertz, and one of them is running at 15 hertz, because I'm using different update substeps for them. Now, the idea is, in a good system, if you do that, they should remain in sync with each other. Even though they've got different delta T values, the thing is, if your system is compensating for that correctly, they should actually still remain in sync. And that includes when you do kind of things like switching gravity on, they should sort of remain in sync with each other. It's very easy to get this wrong, by the way, right? One of the bugs that you'll encounter when you do it is they'll bounce differently when they hit the ground. And this is one of the things you have to fix. You have to figure out what's the right way of doing it, so that even though they're running with different delta T values, they all end up detecting the collision in the same way. It's a little bit tricky. But the end of the result is you end up with 3 spaceships that you can dance around with and have a merry old time, like that. Let's see if there's anything else I need to mention. Yep, I think that's basically it. Those are the fundamentals, and I'll talk about it a bit more on Wednesday. This one's a little bit tricky, so I would advise you to come to the tutorial on Wednesday, have a go at it, and come along being ready to deal with any troubles that you run into for this thing. I mean, it's not super hard, but it can be a little bit subtle. Okay.